Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to start discussing chapter 4, differentiation. This is the course Math 103 and Math 103B. Um, me- so today we will start differentiation. This is chapter 4. Now, our objectives today are first recognize the notation of prime of x and dy by dx for derivative of a function, and then differentiate power functions. So we are going to or trying to achieve those two objectives. Let's have a quick revision about differentiation. Our approach in order to introduce derivatives it will be very simple. It will not be the same as the approach that is used by engineering or mathematician. Just look at this function. As you see at this function, the tangent is different at each time. So at this point, the tangent is the tangent of the function, and at this point the tangent is represented by this line, and as you see the tangent at this point is represented by this line, and so on. Now the derivative equals the slope of the tangent, which means that at this point the slope of this tangent equals the derivative. So the derivative here is the slope of the tangent. So the slope of the graph of a function is called the derivative of the function. It's interesting to notice that corresponding to each value of x, there is a unique defined derivative f prime of x. So as you see that the derivative f prime equals the slope of the tangent. So f prime, or the derivative of the function at any point, equals the derivative of the slope of the tangent at that point. So if I want to find the derivative of the function at this point, let's say x equals a, then the slope of the tangent represents the derivative. So the slope equals f prime of a. So the derivative of the function at point A equals the tangent of the slope at this point. There is an alternative notation for the derivative function. Instead of f prime of x, we are using dy by dx. Dy by dx. You carried it as dy by dx. So whenever you are requested to find f prime of x or dy or by dx, this means that you are requested to differentiate the function. We are going to use the main rule, the main formula in this chapter, or this section, which is power rule. Now, the power rule states that if f prime of x equals x to the power n, then f prime of x, or f dash of x, equals what's happened here. N is coming in front of x, and n also is reduced by 1. So this will be n x to the power n minus 1. So as you see, the power here comes in front of the function, and the power has been reduced by 1, or we subtracted 1 from the power. So the process of finding the derivative function rather than using graph is known differentiation. In order to differentiate x to the power n, all what you need is to bring the power down in front, and then subtract 1 from the power. And this is explained here. X to the power n, this is n x to the power n minus 1, subtract n from the power, and n bring it down in front of the function. So as you see, it's very simple to have or to find out the differentiation or the derivative. As this is the main formula. If f of x equals x to the power n, then f prime of x equals n x to the power n minus 1. So as you see, it's all about the power. So we are going to find out the derivative of this function, power function, in details by taking the cases of power case by case. Case number 1, we will discuss the case in which the power is a positive integer. Power is positive integer. For example, so I have this example number 1 and this is example number 2. If we have if x equals x to the power 2 or x squared, then f prime, as you see, 2 is coming here or is coming in front of x. So it will be 2x to the power 2 minus 1, 2x to the power 2 minus 1, which is 2x to the power 1 or 2x. It's very simple, as you see. If x, example number 2, x to the power 15, then if prime of dash of x equals 15, x to the power 15 minus 1, and I know now you can find it easily and very quickly. This is 15 x to the power 14. So this is case number 1 in which the power is a positive integer. The power is a positive integer. Let's go to case number 2. What if the power is negative? There is nothing you are going to change. We are going to apply the same rule. If f of x equals x to the power n, then f prime of x equals n x to the power n minus 1, no matter what is the nature of the power. Let's have an example. Example number 1, suppose that f of x equals x to the power minus 3. As you see, power is integer but negative, minus. Then f prime of x, again minus 3, it's becoming in front of the function, so it's be minus 3, and the power is reduced by 1. So this is minus 3 x to the power minus 3 minus 1. Now don't forget that minus 3 minus 1 is minus 4, not minus 2. Okay, this is one of the common mistakes that students are usually have. Now, sometimes the power is given minus but indirectly. Suppose that, for example, number 2, you have f x 1 over x to the power 6. Now, x to the power 6, the power is positive, but wait a minute. This function is not ready yet to be differentiated. Why? Because in our level, we cannot differentiate any function located down, located at the denominator. Okay? So first, you have to raise this function up to that numerator in order to be differentiated, in order you can differentiate it. So I'm going to raise x to the power 6 from down to up, from denominator to numerator. And I know when I do this, I have to change the sign of the power. So this is x to the power 6 down, it becomes x to the power minus 6 up. So now f of x equals x to the power minus 6, now start differentiating. If dash of x equals minus 6, x to the power minus 6 minus 1, so if prime of x equals x to the power minus 6, x to the power minus 7. Now it's your turn. I want you to differentiate x to the power 3 positive power, x to the power 25 power, while those two examples represent negative power. Now it's your turn to solve. Let's go to case number 3. In case number 3, the power is positive, but it's not integer. It is fraction. Fraction, it takes the form of a over b. Again, we are going to use the same power, x to the power n, f prime n, x to the power minus 1. It doesn't matter again. Let's have example. Example number 1, f of x equals x to the power 3 over 2. So how much is f prime of x? 3 over 2. Now it's a multiple. It's coming in front of x. So 3 over 2, x to the power 3 over 2 minus 1. Now, wait a minute, 3 over 2 minus 1, this is subtraction of fraction. Don't forget that if we have 3 over 2 minus 1, this is 1 over 1, you have to make the two denominator the same to find least common multiple. So it is very simple, just multiply here by 2 and here multiply here by 2. This is 3 over 2 minus 2 over 2. So finally, this is the same denominator 2, 3 minus 2, it is 1. But each time we are not going to do all this. So there's a very simple approach in order to find out the result of subtraction of two fractions. It's very simple. Now every time we are subtracting 1. So instead of writing 1, I can write 2 over 2, 3 over 3, 5 over 5, 10 over 10. So I'm going to express 1 in terms of the number which is located down at the denominator. So if the number here is 2, so I'm going to express 1, 2 over 2. If it is 3, so I'm going to express 3 over 3. If it is 5, 5 over 5. Okay? So this is, if you do like this, then 3 over 2, 3 minus 2. Instead of 1, I'm going to write 2 over 2. Now I have the same denominator, 2. 3 minus 2 equals to 1. Now, again, sometimes you are given positive fraction indirectly. If you are given a function which is using radical sign. For this example, f of x equals fifth root of x to the power 8. Again, I can't differentiate for our level. to our level, you will not be equipped with the formula that helps you in order to differentiate a function like this. F of x equals fifth root of x to the power 8. So you have to change from radical sign to exponent. How? By using this formula I told you before. You are going to use this formula in logarithm, natural logarithm, and also in differentiation. If you apply this formula, then x fifth root of x to the power 8 you will be written as 8 over 5. As you see, 5, which is the index outside the root, will be down, and the power inside the root will be up at the numerator. So f of x equals x to the power 8 over 5. Then f prime of x equals 8 over 5 x to the power 8 over 5 minus 1. But because the denominator here is 5, I have written 1 as 5 over 5. So this is 8 over 5 x to the power 5 is the same, and 8 minus 5, it is 3. So f prime of x equals 8 over 3. What about case number 4, in which the power is negative function? Now x to the power minus 3 over 5, it is the same, minus f prime equals x to the power minus 3 over 5, x to the power minus 3 over 5 minus, again, 5 over 5. So this is minus 3 over 5, x to the power minus 8 over 5. Another example, again, what if you are given the function in terms of radical sign and it is down? Now, first of all, the function is not ready. Why? Because I have two things to do before the function is going to be ready. First, I have to change from radical sign to exponent. Number two, I have to change the function from down to up, from denominator to numerator. So let me do it one by one. The first, I have to change by using this formula from radical sign to exponent. So cube root of x to the power 4, this is x to the power 3 over 4. Then I have to change the position from down to up by changing the power. So finally, f of x, see, I did not write f prime of x. I start with f of x, here still f of x, and here also still f of x. I'm here still preparing the function to be differentiated, okay, to be differentiated. So f of x equals x to the power minus 3 over 4 minus 3 over 4. Now the function is differentiable. So now start differentiating. As you see, I start using f prime. So f prime equals minus 3 over 4 x to the power minus 3 over 4 minus 4 over 4. And finally, f prime of x equals minus 3 over 4 x to the power minus 7 over 4. It's your turn again. Find, differentiate, or find f prime of x, or dy by dx of f of x equals x to the power 1/3 x to the power minus 2 over 7, f of x equals 8 root of x cubed, and f of x equals 1 over 5th root of x squared. Now, what if I have constant function? Constant function, the function is constant. F of x equals 5, 3, 2, 100, there is no variable. The function, when the function is constant, there is no variable. F of x equals to constant. When f of x equals to constant, the rule is f prime equals to 0. So whenever the function is constant, no variable, then f prime directly equals to 0. I'll give you some examples, some quick examples. F of x equals 100, no variable, no x, y, z. F of x equals pi over 2, constant, no variable. F of x equals square root of 10 to the power 3, again, no variable, so it's constant. In all of these cases, f prime equals, as you see, 0. So as long as the function is constant, then f prime is 0. What if I have a coefficient multiplied by the function? There is c. C is constant number, real number, 5, 3 minus 2, 3 over 2, half, any number multiplied by x to the power n. Then at this case, if prime equals, you are going to multiply c, no change, and differentiate the function as we learn in x to the power n minus 1. Take this example, example number 1. F of x equals 10 x to the power 4. Now there is 10 coefficient of x to the power 4, or this is a multiple. So if prime, then you will go to find out 10, then start differentiating x to the power 4. This is 4 x to the power 4 minus 1. Then multiply 10 times 4, this is 40. So finally, this is 40 x to the power 3. Take this example, example number 2. F of x equals minus 4 over x squared. Now the function is not ready. Why? Because x squared is located down. It should be located up. So move it up, it will be minus 4, this is of x. I must start differentiating it. f of x equals minus 4 x to the power minus 2. Now start differentiating. Minus 4, it will be multiple. Then differentiate x to the power minus 2. It is minus 2 x to the power minus 2 minus 1. Now multiply minus 4 times minus 2. It is plus 8. And x to the power minus 2 minus 1. This is x to the power minus 3. Another rule, another important rule. If f of x equals m times x, m, it is a coefficient, and don't forget that it's x to the power 1. This is valid just when x equal to the power 1. Then f prime of x equals m, or the slope, or the coefficient. When f of x equals mx, then f prime of x equals to m, the constant or the coefficient, the number which is multiplied by x. Take this example. If f of x equals 6x, then f prime of x equals 6. When f of x equals 5 over 2 times x, then f prime equals 5 over 2. When f of x equals x to the power 3, don't forget that x to the power 3, it can be written as third x. Then f prime of x equals to 1/3. So when f of x equals mx, then f prime of x equals to m. Now it is your turn again. Differentiate. F of x equals 8x cubed, f of x equals minus 7 divided by square root of x to the power 5, f of x equals minus 8x, and f of x equals minus 2x over 7. What if, this is the last point I'm going to discuss today. What if I have differentiate this long function? I have here 4 terms, not just one term. Well, you are going to use the same rule, or the cases, you have to apply the cases that we discussed before. I have f of x equals minus 8x to the power 4 plus all these terms. First of all, ask yourself, are all items or terms in the function ready to be differentiated? Let's check. This is ready, but this is not ready. This is ready, and this is not ready. Why this term is not ready? Because it's written in the radical sign. This is first. Number two, it is written down, so it should be up. So here we have 2 stages in order to be differentiated. And this function, it should be down. It is just one thing you have to do in order to be differentiated. So the first step, I have to differentiate or to prepare the function to differentiate. So the second step, I still f of x. I did not start differentiating. So this will be left without any change. Here, fourth root of x to the power 5, it's written as x to the power 5 over 4, and this is x to the power 1. The last stage, this is 8, x to the minus 8, x to the power 4, and this is 3, x to the power 5 over 4, and it's raised up, x to the power minus 5 over 4, and this is x to the power minus 1, 4, x to the power minus 1. Now, start differentiating. This is 4 times 8 minus 32, 4 minus 1 is 3, and this is minus 5, it becomes here, it will be 3 times 5 over 4, x to the power minus 5 over 4 minus 4 over 4, and this is it comes here, minus 1 times 4 minus 4, x to the power minus 1 minus 1 minus 2. So the final answer is f prime equals minus 32x cubed minus 15 over 4 x to the power minus 9 over 4 minus 4 x to the power minus 2. Now it's your turn to differentiate. F of x equals minus 2x to the minus 4 plus 6 over x to the power 5 minus 3 fifth root of x to the power 4 plus 3 over 4 to the power 5. This is the last mission I'm going to ask you to do. Thanking you. Thank you very much.